10 of round 1 of the Maths Teams Olympiad competition. This question was the challenge question. The solution to it is fairly simple to understand, and it doesn't use any extremely complex maths. So I'm expecting a few teams to have solved this, but I'm going to be walking through the solution now. It has many solutions. I'm going to be going for a solution that doesn't contain any calculus, but there are solutions with calculus, and all 4 solutions will receive 4 marks, no matter what the method is. So firstly, note that if you have a triangle, then A plus B plus C will equal 180 or pi. Furthermore, from that, we can say that C, I'll just do it in red, we can say C is equal to 180 minus A minus B. Taking tan of C, well, tan of C is the same as tan of 180 minus A minus B. Well, tan is periodic around 180 degrees. That is to say the graph repeats itself every 180 degrees, so that is the exact same thing of tan minus A minus B. So we've got it in a simplified form so far, but there's also minuses, and I don't like minuses because it's like a degrees and there's minus. I want a positive number of degrees, so I'm going to sort that out by using the fact that tan x is an odd function. So odd function just means that f of minus x is equivalent to minus f of x. And tan is an odd function, so tan of minus x is equivalent to minus tan of x. And this allows us to simplify this further to be minus tan A plus B. Nice. We've got it in a nice form of the sum of 2 angles, and I'm sure you can guess where I'm going from here. I'm going to use the angle sum formula. So that's going to be tan A plus tan B over 1 minus tan A tan B. Nice. I'm going to distribute this minus 1, because I've once again got a minus tan AB. I'm just going to distribute that into the bottom, just to make this a positive. So this is all valid, and you would get tan A plus tan B over tan A tan B minus 1. Nice. And we've got this equal to tan C. So from then on, it would be obvious to multiply out and rearrange. And when you do that, you get tan A plus tan B plus tan C equals the product of the tans of the angles tan C. So nice, we've got an interesting result here, that the sum of the tans of the angles is equal to the product of the tans of the angles. And from then on, you could use calculus. I'm going to show a different way to go for it. So recall the AM-GM inequality. So keep in mind, this is a very important inequality, and it's come up in previous questions, and it will probably come up in further rounds. So make sure you're familiar with it. It states that the sum of the mean of n real numbers is always going to be greater than or equal to the mth root of the real numbers. You could say positive numbers because it may always not be real on the nth root. Applying AM-GM on tan A, tan B, tan C, you get tan A plus tan B plus tan C all over 3 is greater than or equal to the cube root of the product of them. Tan A, tan B, tan C. So that's just a known. Sorry for changing of the colours. If you multiply through out by 3, you get tan A plus tan B plus tan C is always going to be greater than the cube root, 3 times the cube root of tan A, tan B, tan C. Recalling down here, well, we've already proved that tan A, tan B, tan C is equivalent to tan A plus tan B plus tan C. So we can change this here to this, and I'll do that right now. So we can change this inequality to be tan A, tan B, tan C is all greater than 3 times the cube root of tan A, tan B, tan C. Nice. So, well, you can cube both sides, and then you get tan A, tan B, tan C cubed is greater than or equal to 27 tan A, tan B, tan C. Divide through, you get tan A, tan B, tan C squared is greater than or equal to 27. Nice. So you can take the cube root of both sides to get tan A, tan B, tan C. No, not the cube root, the square root, pardon me, is greater than the square root of 27, which is 3 root 3. And that is your final result. Nice.